Question 1. While examining a rooftop unit in a strip mall, technician Alvarez discovers intermittent compressor operation. The thermostat appears to be calling for cooling, but the compressor doesn't always respond. She observes a delay when the thermostat cycles off and back on. She suspects the issue lies in the low-voltage control circuit. What is the most appropriate next diagnostic step? A. Replace the thermostat immediately to eliminate a faulty signal source. B. Measure voltage across the contactor coil while cycling the thermostat. C. Check compressor continuity using an ohmmeter. D. Disconnect the control board to reset the logic sequence. Answer. Correct answer. B. Measure voltage across the contactor coil while cycling the thermostat. Explanation. In light commercial systems, intermittent operation can be caused by poor, low-voltage signal delivery. Measuring voltage across the contactor coil while the thermostat cycles helps verify whether the call for cooling is reaching the compressor relay. Replacing the thermostat without confirming signal delivery is premature. Checking compressor continuity irrelevant at this stage. Disconnecting the control board without diagnosis risks creating new faults. NEC 2023 Article 430 and ANSI 135 emphasize verifying signal integrity and control sequence logic before component replacement. Question 2. Contrary to popular belief, topping off a system low on R400T refrigerant is not always the correct service action. Which of the following best explains why this approach can be problematic? A. The EPA prohibits topping off any HVACR systems. R400T cannot be recharged once a leak is detected. C. The system must first be leak checked and repaired before adding refrigerant. D. Topping off reduces subcooling and increases compressor capacity. Answer. Correct answer. C. The system must first be leak checked and repaired before adding refrigerant. Explanation. Under EPA Section 608 regulations, technicians must repair leaks in systems with over 50 pounds of refrigerant if the leak rate exceeds thresholds. Even below that level, best practice requires diagnosing the cause of low charge before recharging. Topping off without leak detection risks ongoing environmental release. Subcooling and compressor capacity are not improved by topping off without system integrity. OSHA 29 CFR 1910.147 also requires lockout-to-gut procedures when servicing pressurized components. Question 3. Given the circumstances, Mr. Chan is troubleshooting a packaged rooftop unit in a medical clinic. The unit runs continuously, but the indoor temperature remains well above the thermostat set point. Suction pressures are low, and the evaporator coil shows signs of frosting. The blower motor is operational. What should Mr. Chan investigate next? A. Inspect for a faulty reversing valve. B. Test the thermostat's anticipator setting. C. Check the evaporator metering device for restriction. D. Adjust the blower motor speed for higher airflow. Answer. Correct answer. C. Check the evaporator metering device for restriction. Explanation. A restricted metering device, GTXV or orifice, can cause low suction pressure and frosting of the evaporator due to inadequate refrigerant flow. This results in poor heat absorption and ineffective cooling. A faulty reversing valve applies only in heat pumps. Anticipators affect cycling behavior, not refrigerant flow, while blower speed can airflow restriction must be ruled out first. ASHRAE Guideline 14 and INC Section 1106 support verifying refrigerant flow devices when diagnosing coil freezing. Question 4. The foundation of professional service includes proper documentation. Which of the following actions best aligns with standard HVACR documentation protocols following a maintenance visit? A. Only record the invoice and customer signature. Other data is unnecessary. B. Log refrigerant pressures, voltages, filter status, and actions taken. C. Leave a business card and verbally explain findings. D. Record maintenance steps only if repairs were made. Answer. Correct answer. B. Log refrigerant pressures, voltages, filter status, and actions taken. Explanation. Comprehensive documentation ensures accountability, legal compliance, and technical traceability. ASHRAE Standard 180 and EPA documentation guidelines require recording operational metrics, maintenance actions, and system status. Leaving only a business card or informal verbal summaries fails to meet professional or regulatory standards. Detailed logs also help future technicians diagnose issues. Proper documentation is also part of ANSI 4QM standard for maintenance of commercial HVAC systems. Question 5. Throughout the course of performing a system replacement at a small restaurant, technician Rivera realizes the existing rooftop unit is undersized, especially during peak lunch hours. What is the most appropriate method to determine the correct system capacity? A. Use nameplate data from the old unit to match size. B. Install the next size up for future expansion. C. Perform a manual N or equivalent load calculation. D. Estimate based on square footage and local climate. Answer. Correct answer. C. Perform a manual N or equivalent load calculation. Explanation. Proper sizing requires load calculations accounting for internal gains, occupancy, infiltration, orientation, and insulation levels. Manual N for commercial or its equivalent is the industry standard. Guessing by square footage or simply upsizing risks oversizing, poor humidity control, and energy waste. In Section 312 an ASHRAE Handbook, fundamentals outline procedures for accurate commercial HVAC load calculations. HVACR professionals must avoid assumptions and use data-driven approaches. Question 6. To illustrate this point, Mr. Gonzalez is brazing a suction line on a rooftop package unit. He has purged the system with nitrogen, but oxidation still forms inside the pipe. What likely went wrong? A. Nitrogen was introduced too late in the process. B. A flux designed for soldering was applied instead of brazing flux. C. The pipe material was incompatible with nitrogen. D. Oxygen was used to purge the pipe before brazing. Answer. Correct answer A. Nitrogen was introduced too late in the process. Explanation. During brazing, nitrogen must be continuously flowed during the heating process to prevent oxidation and scale black flakes inside the tubing. If introduced only after heating, oxidation occurs due to the presence of air. Using flux is more applicable to soldering, not brazing of refrigerant lines. Pipe materials like copper are compatible with nitrogen. ASHRAE Standard 15 and HVAC guidelines emphasize proper purging procedures for system integrity and performance. Question 7. By evaluating an office compact HVAC system, technician Brooks finds poor airflow in corner offices, although static pressure readings are within limits. Ductwork appears correctly sized. What is the most plausible root cause? A. Undersized main supply trunk line. B. Unbalanced dampers or improperly set diffusers. C. Oversized return grills. D. Leaking refrigerant lines. Answer. Correct answer. B. Unbalanced dampers or improperly set diffusers. Explanation. Even with proper duct sizing and static pressure, air distribution problems often result from unbalanced branch dampers or diffuser settings, which control directional airflow. These adjustments are critical for delivering conditioned air evenly. Refrigerant leaks do not directly cause airflow imbalance. Oversized returns would affect return velocity, not directional airflow. ASHRAE 62.1 and SMACNA HVAC air duct leakage test manual stress the importance of balancing for occupant comfort and efficiency. Question 8. In the context of lockout-out procedures, what is the correct sequence for the technician to follow before servicing the electrical compartment of a roofed HVAC unit? A. Remove the fuses, open the disconnect, then tag the panel. B. Shut off power, lockout tag, then verify absence of voltage. C. Open the disconnect switch, test voltage, then tag the panel. D. Notify management, remove wiring, then place a lockout device. Answer. Correct answer. B. Shut off power, lockout tag, then verify absence of voltage. Explanation. According to OSHA 29 CFR 1910.147, the proper lockout-out procedure is to shut down equipment, isolate energy sources, apply lockout-out, and verify zero energy. This ensures safety from electrical shock or arc flash. Skipping verification or removing wiring before isolating power violates Protocol. NFPA 7I Article 120.5 also mandates testing for absence of voltage with a properly rated tester after lockout. Question 9. Taking into account a light commercial split system that frequently trips its high-pressure switch, technician Mr. Wallace notes that the condenser fan runs, but coil fins are extremely dirty. What's the first course of corrective action? A. Replace the high-pressure switch. B. Add refrigerant to reduce head pressure. C. Clean the condenser coil thoroughly. D. Adjust the blower motor speed for balance. Answer. Correct answer. C. Clean the condenser coil thoroughly. Explanation. A dirty condenser coil prevents effective heat rejection, causing head pressure to rise and trip the high-pressure switch. Cleaning is the first logical action before replacing components or adjusting charge. Adding refrigerant will worsen the condition. The blower motor has no direct effect on condenser performance. ASHRAE 180 and manufacturer or her manuals mandate regular coil cleaning as part of maintenance to prevent system overpressure. Question 10. With the advent of advanced building controls, technician Mr. Nash is integrating a rooftop unit with the facility's BAS system. The unit works fine manually but fails to respond to BAS commands. What's the most probable cause? A. The BAS controller is improperly grounded. B. Manual control mode was not switched to BAS input mode. C. The unit's refrigerant charge is too low. D. The economizer damper is stuck open. Answer. Correct answer. B. Manual control mode was not switched to BAS input mode. Explanation. Many HVACR units require a manual BAS toggle to enable external control. If left in manual, the BAS cannot override internal settings, while grounding is essential. Improper control mode is a more direct cause. Refrigerant charge affects cooling, not control communication. Economizer issues affect air intake, not command. Interpretation. ASHRAE Guideline 13 and BACnet protocols dictate proper system integration steps for control functionality. Question 11. In a modern context of energy-efficient systems, technician Mr. Jameson observes erratic compressor cycling in a light commercial unit. Using a multimeter, he finds 280 V across the compressor contactor but no current flow to the compressor. Resistance readings at the windings are within spec. What should he investigate next? A. The control board logic has failed and needs replacement. B. The contactor is mechanically closed but has pitted contacts preventing continuity. C. The compressor capacitor is incorrectly rated, preventing startup. D. The refrigerant is low, preventing operation. Answer. Correct answer. B. The contactor is mechanically closed but has pitted contacts preventing continuity. Explanation. A closed contactor with proper voltage but no current flow often indicates internal pitting or carbon buildup, causing an open electrical path. This is a common issue in aged contactors under inductive loads. A failed capacitor would more likely show initial current than trip, not zero flow. Low refrigerant does not prevent current. A contactor. NEC Article 430.83 and NETA testing standards recommend verifying contact integrity as part of troubleshooting. Question 12. With respect to heat pump heating mode, Ispatel is troubleshooting a system that runs continuously but fails to maintain indoor temperature during cold weather. The reversing valve has been verified operational. Indoor airflow is nominal. What should be her next step? A. Bypass the defrost control to force backup heat. B. Test outdoor coil temperature sensor for accurate defrost initiation. C. Verify operation of supplemental electric heat strips. D. Add refrigerant to improve heat transfer. Answer. Correct answer. C. Verify operation of supplemental electric heat strips. Explanation. Heat pumps require supplemental heating in low ambient conditions. If strips aren't energized when needed, the system can't meet demand. This is especially critical in light commercial applications. Improper sensor operation might affect defrost but not total heat output. Refrigerant undercharge would typically show in pressures, but strips must be checked first. To NEC 424 and manufacturer control logic for correct heat strip sequencing and operation. Question 13. Among the various HVAC system types, why might a ductless mini-split system be inappropriate for certain light commercial environments, such as an open retail space? A. Mini-splits are incompatible with modern refrigerants like R400 TINA. B. These systems require extensive ducting for proper airflow. C. Zoning capability may not match open space demands. D. Their compressors are designed only for residential voltage levels. Answer. Correct answer. Seat owning capability may not match open space demands. Explanation. Ductless mini splits excel in zoned environments but may struggle in large open commercial spaces where uniform airflow is critical. These systems can leave dead zones unless carefully configured. They are compatible with R400 TINA and operate on commercial voltages. Extensive ducting is not required. This is actually benefit ASHRAE handbook. HVAC systems and equipment notes application limitations of mini splits in open commercial layouts. Question 14. During the process of a scheduled quarterly service Mr. Liang is performing a maintenance check on a rooftop unit. He records system pressures, verifies voltage, and checks belt tension. Which additional step is critical to ensure proper preventative maintenance? A. Resetting the thermostat to factory defaults. B. Disabling the economizer to reduce load. C. Inspecting and cleaning the condensate drain line. D. Replacing the heat exchanger gaskets. Answer. Correct answer. C. Inspecting and cleaning the condensate drain line. Explanation. Clogged condensate lines can cause overflow, water damage, and microbial growth. As part of preventative maintenance, cleaning and flushing the line is essential, especially in humid environments. Resetting thermostats or disabling economizers are unnecessary and could disrupt control logic. Heat exchanger gaskets are only replaced during repairs or replacement. ASHRAE 180 and manufacturer PM guidelines include condensate system checks as standard maintenance. Question 15. Focusing specifically on a walk-in freezer, technician Mr. Rees observes that the suction pressure is unusually high while product temperature is still rising. The compressor is running continuously and AM draw is normal. What condition is most likely? A. The defrost cycle has not terminated. B. There is an evaporator fan motor failure. C. The expansion valve is stuck open. D. The condenser coil is iced over. Answer. Correct answer. C. The expansion valve is stuck open. Explanation. A stuck open TXV floods the evaporator, reducing superheat and causing high suction pressure without effective cooling. This results in rising box temperature despite normal compressor operation. Ice condensers affect head pressure, not suction. A failed evaporator fan would reduce airflow but usually causes low suction. ASHRAE Refrigeration Handbook recommends inspecting ESV function when suction pressure is inconsistent with load conditions. Question 16. The impact of diagnostic tools on system performance is critical. Technician Iskar is testing a system using analog manifold gauges. She reports inconsistent readings across test sessions. What may be the primary issue? A. The gauges are incompatible with R400 TINA systems. B. She is not zeroing the gauge before each use. C. The system does not have Schrader valves. D. There is air in the refrigerant lines. Answer. Correct answer. B. She is not zeroing the gauge before each use. Explanation. Analog gauges must be zeroed before each use to account for pressure drift due to altitude, temperature, or damage. Inconsistent readings result from skipping this step. Digital gauges reduce this issue. R400 TINA compatibility refers to pressure range, not accuracy. Schrader valves are required on modern service ports. Air in lines affects readings, but is less likely than operator error. EPA Section 608 and ASAE's training emphasize gauge calibration as standard procedure. Question 17. From a practical standpoint, when recovering refrigerant from a light commercial unit with over 15 pounds of R400 TINA, what must the technician do before charging the system again? A. Evacuate the system to 500 microns in record recovery weight. B. Only check superheat and subcooling to ensure correct charge. C. Add new refrigerant without documenting recovery. D. Flush the system with water to remove contaminants. Answer. Correct answer A. Evacuate the system to 500 microns in record recovery weight. Explanation. EPA Section 608 requires recovery and documentation of refrigerant before recharging. The system must then be evacuated to 500 microns or lower to ensure removal of moisture and air. Superheats or cooling are used during charging but are not substitutes for evacuation. Flushing with water is prohibited and contamination. Documentation ensures legal compliance and system reliability. Question 18. To what degree does a failed current sensing relay affect compressor operation in the capacitor start induction run motor? A. It can cause short cycling due to delayed run winding activation. B. It prevents the start winding from disengaging, risking motor damage. C. It increases system efficiency by bypassing the start winding early. D. It allows the system to run in defrost mode continuously. Answer. Correct answer. B. It prevents the start winding from disengaging, risking motor damage. Explanation. A failed current relay can trap the start winding in circuit, leading to overheating and potential winding failure. The start winding must disengage shortly after motor acceleration. Defrost mode is unrelated. Efficiency isn't improved by improper timing. NEC 430 and NEMA MG1 standards support proper starting function for motor protection. Question 19. The general consensus is that low ambient temperatures present challenges for rooftop HVAC operation. Technician is asked to commission a unit in a region with frequent winter temperatures below 10 degrees. What measure should she prioritize? A. Adjust the refrigerant charge for colder temperatures. B. Disable the outdoor fan to reduce head pressure. C. Install head pressure control or fan cycling switch. D. Install crankcase heaters to prevent icing. Answer. Correct answer. C. Install a head pressure control or fan cycling switch. Explanation. In low ambient conditions, head pressure drops, reducing metering device performance. Head pressure control devices, such as fan cycling switches or split condenser circuits, maintain adequate pressure for TXV operation. Adjusting charge is not an appropriate solution. Crankcase heaters protect the compressor but do not regulate pressure. Refer to ASHRAE Systems Equipment Guidelines and IMC Section 1105 for proper cold weather design strategies. Question 20. When presented with a replacement rooftop unit requiring a three-phase power connection, technician is to Viga wires the disconnect and observes reverse fan rotation. What is the correct solution? A. Reverse the two low-voltage control wires. B. Install a phase detection device to block startup. C. Swap any two incoming power legs. D. Ground the common terminal of the contactor. Answer. Correct answer. C. Swap any two incoming power legs. Explanation. Three-phase motors run directionally based on the phase sequence. Swapping any two power legs reverses rotation direction. This is the standard solution when fan or compressor rotation is reversed. Low-voltage wires and grounding are unrelated. Phase monitors are used for detection, not correction. NEC Article 430.70 and NEMA MG10 support this action in field installation practices. Question 21. Examining the consequences of an intermittent shutdown issue on a light commercial rooftop unit, technician Mr. Donnelly observes that the system runs for 1015 minutes, then trips the breaker. He checks refrigerant pressures, which appear normal. Electrical readings reveal that the compressor's running amperage gradually increases with time. What should be his next step? A. Test capacitor for correct microfarad racing. B. Measure voltage drop across contactor under load. C. Check airflow restriction across evaporator coil. D. Inspect compressor windings for thermal breakdown. Answer. Correct answer. D. Inspect compressor windings for thermal breakdown. Explanation. Gradually increasing amperage suggests winding insulation is degrading with heat, leading to high resistance. This can cause thermal overload or breaker trip. Pressure readings may appear normal early in operation. Capacitors typically affect startup, not ramping current. Voltage drop should be checked, but the symptoms align more with winding failure. NEC 430 NEMA MG1 guidelines support winding resistance analysis under thermal load conditions. Question 22. While it is true that many service calls involve technical problems, effective communication often determines customer satisfaction. Technician is Barlow completes a successful repair but doesn't explain the work or leave documentation. The customer later complains. What could she have done differently? A. Avoid unnecessary technical explanations to minimize confusion. B. Only leave paperwork if the customer requests it. C. Clearly explain the issue, the solution, and preventive tips in writing. D. Focus on speed and avoid spending too much time after service. Answer. Correct answer. C. Clearly explain the issue, the solution, and preventive tips in writing. Explanation. Professional HVACR service includes clear documentation and communication explaining the diagnosis and repairs in accessible terms, builds trust and avoids disputes. Providing preventive tips also demonstrates value. ASHRAE's HVAC customer service guidelines and account quality installation standards both emphasize strong communication as part of quality service delivery. Question 23. To better understand persistent complaints about stale air in a conference room, technician Isterford measures airflow and finds adequate CFM, but occupants report stuffiness. CO levels are elevated. What is the most probable cause? A. Ductwork has collapsed in the ceiling space. B. Return air is recirculating without sufficient fresh air intake. C. Cooling coil is freezing intermittently. D. The thermostat is too close to heat source. Answer. Correct answer. B. Return air is recirculating without sufficient fresh air intake. Explanation. Elevated CO levels indicate poor ventilation even if airflow volume seems sufficient. The return air may be circulating internally with little or no outside air, which is common in economizer or damper control issues. ASHRAE Standard 62.1 sets minimum outdoor air requirements based on occupancy type and load. Frozen coil or thermostat placement would not explain high CO concentrations. Question 24. By comparing the performance of two identical rooftop units, Thomas notices that one unit responds sluggishly to zone temperature changes while the other operates normally under BAS control. She checks sensor calibrations, which appear fine. What should she investigate next? A. BAS loop response delay or PID tuning for the zone. B. Unit refrigerant charge and suction pressure. C. Motor winding resistance of the supply fan. D. Humidity sensor placement near the return duct. Answer. Correct answer. A. BAS loop response delay or PID tuning for the zone. Explanation. Control loop parameters, especially proportional integral derivative PID settings, impact how quickly the system reacts to changes. Poorly tuned loop can delay actuator commands or cause overshooting. BAS responsiveness is key in zone-like commercial setups. ASHRAE Guideline 13 and BACnet application notes recommend proper PID tuning for responsive zone control and energy efficiency. Question 25. From multiple perspectives, technician Isterkint uses a digital multimeter to measure resistance on a compressor and Seasol open loop on all terminals. What does this most likely indicate? A. High refrigerant pressure locking the windings. B. A blown internal overload or open winding. C. Incorrect scale setting on the multimeter. D. Faulty capacitor connected in circuit. Answer. Correct answer. B. A blown internal overload or open winding. Explanation. An open circuit on all terminals typically means a burned winding or tripped internal overload in the compressor. The overload may reset once the compressor cools. The multimeter's scale wouldn't show. If it were incorrect, it would show 0 or erratic. Capacitors are not involved in winding continuity readings. NEC 430 and HRConquer materials recommend resistance checks for evaluating motor health. Question 26. A critical examination of HVACR business practices shows that ethical lapses often result from performance pressure. Technician Ortega is asked by a manager to upsell services the client doesn't need to meet quota. What is the correct ethical action? A. Offer the service but mark it as optional. B. Decline to upsell and report the request to upper management. C. Ignore the manager and continue work without telling anyone. D. Tell the customer the unit is likely to fail unless upgraded. Answer. Correct answer. B. Decline to upsell and report the request to upper management. Explanation. Honesty and transparency are core ethical standards in HVACR service. Pressuring clients to buy unneeded services breaches professional integrity. Technicians are responsible for ethical conduct and should report such behavior. The Code of Ethics and HVAC excellence programs highlight the duty to serve in the customer's best interest. Question 27. In light of recent developments in refrigerant handling safety, Mr. Benson is preparing to evacuate a rooftop unit. Which safety step must be completed before connecting the recovery machine? A. Energize the compressor to push refrigerant into the condenser. B. Apply a vacuum to the liquid line to prevent blowback. C. Don appropriate PPE and verify refrigerant type and pressure. D. Remove the filter dryer to reduce restriction during recovery. Answer. Correct answer. C. Don appropriate PPE and verify refrigerant type and pressure. Explanation. PPE is required by OSHA 29 CFR 1910.132, and confirming refrigerant type ensures that the recovery tank and machine are compatible. This avoids cross-contamination or system damage. Pulling a vacuum before recovery is dangerous and incorrect. Energizing the compressor is unnecessary and unsafe. Removing the filter dryer is not required prior to recovery. EPA Section 608 and Manufacturer Safety Manuals stress PPE and refrigerant ID verification. Question 20. The underlying principle of defrost cycles in heat pumps is to reverse refrigerant flow to melt ice. Technician is Silver notes that during defrost mode, steam rises from the outdoor coil and customers believe there's fire. What should she do to address this concern? A. Instruct the customer that steam during defrost is normal. B. Bypass the defrost board to reduce cycle frequency. C. Install condensate heater below the coil. D. Adjust the T6V for faster refrigerant flow. Answer. Correct answer. A. Instruct the customer that steam during defrost is normal. Explanation. Steam during defrost is normal and occurs when warm refrigerant melts frost. The heat causes water vapor to rise from the coil. This is not smoke or fire. Technicians should educate customers on this normal function. Adjusting ESVS or control boards is inappropriate. ASHRAE Fundamentals and Manufacturer Service Bulletins note this as a common misunderstanding requiring explanation, not mechanical intervention. Question 29. Historically speaking, rule of thumb sizing has caused system inefficiencies. Technician Istor alloys replacing a rooftop unit in a church building. Why is it critical to perform a formal load calculation? A. Older systems were oversized and codes now mandate right sizing. B. Modern units no longer support oversized cooling cycles. C. Codes require units to be selected based on equipment tonnage alone. D. It avoids short cycling even if occupancy increases. Answer. Correct answer. A. Older systems were oversized and codes now mandate right sizing. Explanation. Oversized systems lead to short cycling, humidity issues, and energy waste. Older systems were commonly oversized for safety. Current codes, including IMC 312 and ASHRAE 183, require load calculations that reflect actual occupancy, insulation, infiltration, and usage. Right sizing improves comfort and efficiency, especially in variable occupancy buildings like churches. Question 30. The most significant aspect of system efficiency in light commercial HVAC is not just SEER or EAR ratings. Technician is new and is evaluating an underperforming unit with high energy bills. She notes clean filters and proper charge. What should she examine next? A. Duct insulation, integrity and leakage. B. Bypass the economizer to increase cooling capacity. C. Reduce the outdoor airflow to minimize heat gain. D. Replace the thermostat with a programmable type. Answer. Correct answer. A. Duct insulation, integrity and leakage. Explanation. Even with proper system charge and airflow, duct losses, especially in unconditioned spaces, can reduce efficiency significantly. Leaky or uninsulated ducts waste energy and reduce effective BTU delivery. ASHRAE 90.1 and SMACNA manuals stress duct sealing and insulation as essential to system performance. Bypassing economizers or reducing ventilation violates IMC codes and energy standards.